The other reason I like this old telly is because it's got, see these wires, they're actually rolls of copper wire. So we'll grab it out and I'll show you. This copper wire here that surrounds that CTR, it's pretty stiff. It's probably not worth us using it. We might just recycle that. Here's our ring. I'll just undo it and show you what's inside. Here's our copper coil. The diameter of the wire in this coil is about 0.3. Now just on a final note today, just in relation to this air gap on here that they refer to, I found out what that actually is and what it does, and you learn something new every day. The air gap is just a little bit of, we're going to put a little bit of paper in between there. Well, this is a thicker bit of paper in there, and all it is designed to do is inhibit any saturation of the coils when we put them on there. So that's fair enough. So we'll add that. And so we have our air gap complete. End. So welcome back. In the end, I actually used a iron fence nail, so they're quite long actually, and I hollowed out these bobbins, these sewing bobbins, to 6.5. The shaft is 6.4 mils, so I hollowed them out to 6.5. It's quite a firm fit, still fitted, and I'm able to get my blocking coil and my 10 induction coils as per the schematic or the picture, and yeah, I think it should work all right. The other thing is, there's no mention in the patent what gauge the wire should be. So to give you an example, I've got 1 mil wire here, I've got 0.3 of a mil here, and I've got here this is about 0.67 or 0.66 of a mil. I think what I'll do for the sake of the argument is actually use this one. The reason being is because it came out of an old television, this old CRT. What are they called? Cathode ray tube. And it was used to induce the high voltage around the back. So I figure it's probably made for that, so it'd probably be good for our little device here. So we'll go ahead with that. And I can also fit that in the chuck of a drill. So then it'll make it much easier to count the turns and get the correct amount of turns on each bobbin, if you like. And I figure that sort of diameter, maybe I'll get, I don't know, 60 turns maybe, don't know. Well, here I'm about halfway through getting the tape off the CRT coil. There we have it, one long roll, all the masking tape taken off. Now we're going to have to roll this up onto a some sort of and there's our coil wrapped around that bolt. It ain't pretty, but it's done. So what we'll do is wind the cores next. That is to say, all of these babies. So yep, that's the next job. See how we go. Probably take the magnet off for that. Good morning. Good morning, Max. Here's our setup for winding the coils. Got our spool in this container, which seems to work pretty good. Goes up here. Got our setup connected to a electric drill here, and what I've got here is just a straight lacquer band that goes on the end of the device, and it comes down here to a counter. This is an old counter out of a tape deck, and that's what does the counting for me. And I can tell you, if I can get a close-up of it, we do 50, that's not going to show it very well, 50 turns. Now, I think that the diameter of that if it'll focus. The diameter of that is probably a fair bit bigger than the diameter of our pin here, our nail. So I reckon ended up getting probably 60 turns in there. So we're just going to go ahead and do the rest of them. So they're all the same length. I'm cutting them to a little bit longer, so every second one, so I can join them all together. So then this one here, I'll cut here, etc., etc. Okay, I'll just show you how we do it. Basically, we just turn it, and it has to, that'll count another 50. So basically that's all there is to it. Well, so far I've got 6 out of 10 done, and only got 4 to go. So then we'll check the ohms and make sure that they're all the same length. So there we go, all the coils are wound, all the starts on one side, all the starts on one side and the ends on the other. And these all have to be joined in series. So that'll be the next job, is to tin the ends, join them all together. Righto, so there it is, the completed unit. All the coils have been wound, they're all 7 ohms. Got our leads connected to each one of them, all connected in series. That is to say, no, it might not be series, it might be parallel. All the negatives and all the positives are joined together. And there's our 2 leads, our out leads. So all we really got to do to test this thing is connect it up to our power source, which I'm having a bit of problem with at the moment, but we'll sort something out. Try and make something with a resistor, I think, or DC pulse, or I'll just buy something. Anyway, that should work theoretically. I'll have to cover these, of course, because that's all live, so I have to cover all that. But for now, yeah, that's it.